I'm going to look here now at 2015 and question 6E. So slightly different here. Ethanol can be used as a fuel. So here, instead of being asked for the heat of reaction or the heat change or the heat of combustion, we're asked for the heat of formation of ethanol, given that the heat of combustion of ethanol is that, and that the heats of formation of carbon dioxide and water are that. So the first thing that makes this particularly difficult at the start is that we actually have to balance the equation. So I'm told ethanol is combusted. So that means always reacts with oxygen to produce carbon dioxide and water. So I have C2H5OH, and I'll just redo it out. Always when it's a heat of combustion, it reacts with water to produce carbon dioxide and water. Now, I need to balance. If I look here, ethanol, 2 carbons. So I need to have 2 carbons here. If I look here, I have 5 and 1 H, so that's 6 H's. So I need to have 6 on my right-hand side. 3 by 2 gives me 6. If I look here, I have 4 oxygens and 3 oxygens. So in total on my right-hand side, I have 7 oxygens. 1 is gone in my ethanol, so I need another 6 more, so 3O2. And after that, we're asked this time to calculate the heat of formation of ethanol. So using method 1, which is how I always do it, but I will show you method 2 as well. So in this question, I'm asked for C2H5. So how do I make that? 2 carbons. I have H2 and I need 3 of them to make 6 hydrogens. Plus, and I have only 1 oxygen, so that's a half O2. So that is what I need to be left with at the end. And I'm given 3 pieces of information. Firstly, my heat of combustion of ethanol. And I'm given that as a value of minus 1370.7. And then I'm told the heats of formation of carbon dioxide and of water are minus 393.5 and minus 285.8 respectively. So how do I make carbon dioxide? Carbon plus O2. And how do I make water? H2 plus a half O2. Okay, and what we do now is we compare each of these 3 equations to what I need to end up with. If I look here, ethanol is on my left hand side here, it's on my right hand side here. So I need to reverse this equation. So 2CO2 plus 3H2O goes to C2H5OH plus 3O2. When I reverse the equation, I have to reverse my sign. So that's the first one. Next one here is C plus O2 goes to CO2. And if I look, my C is on both the left-hand sides. So all I need to do here is multiply the whole equation by 2 and multiply my value by 2. So again, onto the calculator, minus 393. Okay, so 393.5 multiplied by 2 gives me minus 787. And finally then, if I look at this, okay, I'm looking at my H2. So here I need to multiply it by 3. That's all. They're both on the left-hand side. So 3H2, and then that's going to be 3 over 2O2. So you just multiply 1 by 3, the top line here, by 3. Okay, that's all you're doing. And that gives 3H2O. And when I multiply minus 285.8 by 3, I get minus 857.4. Okay, and now what we do is, again, we have a look at what we have on our left hand side and what we have on our right hand sides. So anything on the left cancels with anything that also appears on the right. Now, The carbon dioxides cancel, my waters cancel. Now, 3/2 is the same as 1.5 O2. So 3 O2s cancel with 2 and 1. So it leaves me with a half O2. So I have 2C plus 3H2 plus a half O2, and that goes to C2H5OH. And if we look up here, that is the equation that I'm looking for. 2C plus 3H2 plus a half O2 gives C2H5OH, C2H5OH. And what I do then is I simply add all of my figures together. So I have plus 1370.7 minus 787 minus 857.4, and that gives me an answer of minus 273.7, and that's kilojoules per mole. That's using method 1, okay? Now we'll do the same using method 2. Okay, so this time C2H5OH plus, was it 3O2? It was. Going towards 2CO2 plus, and it is 3H2O. Okay. Right, so what I am told this time is that whole reaction is minus 1370.7. So, looking at my formula, it is my delta heat of my reaction equals sigma delta heat of formation of my products minus sigma delta H formation of my reactants. Okay, and again, you have to know that equation off if you are doing this. So this question is slightly different to the last one because in this case, I'm given my delta heat of reaction. So minus 1370.7 equals, and it is the delta heat of formation of my products. So I'm looking for my formation of this. I am told carbon dioxide is minus 393.5. And I'm told water is minus 285.8. So, delta heat of formation, I have 2 carbon dioxide, so 2 by minus 393.5 plus, and again I have 3, and this time I have 3 minus 285.8. Okay, and that's minus the delta heat of formation of my products. My reactants. So it's C2H5OH plus 3. And I'm given no information about oxygen, so it's assumed that that is 0. So I have minus 1370.7 equals. And when I multiply 2 by minus 393.5, I'm going to get minus 787. Plus by a minus gives a minus. So then I have 3 by 285.8. And that gives me minus 857.4. And it is a minus here, C2H5OH. Okay, minus into that. Don't need to do anything with 0. It's going to be 0. So what we're going to do is we obviously have to get this ethanol by itself. Okay, so I'm going to have to bring the ethanol across the equal sign. When I do that, it becomes plus. Okay, and I need to get it on my own. So then this value needs to go across to the right hand side. Again, it changes sign when it does that. So it becomes plus 1370.7. So working that out then, it's 1370.7 minus 787 minus 857.4, and you get the same answer again, which is minus 273.7 kilojoules per mole.